Okay, this is our video on scatterplots. It's for section 2.5, and the first three things here we got are definitions. First one is a definition for a scatterplot. And a scatterplot is a data set with two variables graphed as ordered pairs on a coordinate plane. Okay, again, a scatterplot is a data set with two variables graphed on a coordinate, or graphed as ordered pairs on a coordinate plane. Now remember, your x variable, when you're looking at a chart, the x is going to be your independent variable. Okay, that's the one we can't control. And then the y is going to be your dependent variable. It's the one that depends on whatever x is. Usually x will be some sort of time, either minutes, hours, days, and then the y will be whatever is dependent on the time. How tall you are after so many years. The example we're going to look at later is how many calories are burned after a certain amount of time during a workout. Okay, so x is the one we can't control because time goes on regardless of whatever we do. And then the dependent variable is going to change depending on how long we do something. Okay, the second vocab word is a line of best fit, and it is a line that closely approximates the data. Alright, and it's going to be in, you need to sketch it through 2 points, at least 2 points. And the reason we pick 2 points is so that we can get a slope for the next one here, our prediction equation. But it has to go through at least 2, and there's a couple different ways you can do it. You can kind of go through the middle of your data. You can pick the high and the low. But regardless of what you pick, you're just going to pick 2 points, at least 2 points, and you're going to sketch the line between those 2 points so that it goes with your data. It should follow the data. Don't pick 2 points and then draw a line that looks nothing like the rest of your data set. Okay, the last one is the prediction equation, and it's the equation for the line of best fit. Okay, and it needs to be in slope-intercept form, which is y equals mx plus b. Now the reason we get 2 points from our graph for the line of best fit is so that we can get the slope in our prediction equation. And then we'll pick one of the other two for x and y and solve for b. Now our steps for working out a scatterplot problem, there's 4 of them. The first one is to plot the data. Okay, it's like a relation that's just points, or a function that's points. Everything in our scatterplot is going to be points. It won't be an equation yet. We're going to figure that out. So we need to plot all that data first. We've got to plot all of our points. Our second step is to sketch the line of best fit. And again, it needs to go through at least 2 points, and it should follow our data pretty closely. Step 3 is to determine the prediction equation. And we've done that. That's what we did in 2.4, where you figure out the slope, you plug in x and y, you find b, and you get an equation. So we've done that before. We just need to go through all the steps again to do that. And then 4 is going to be to actually predict something. Our problems are going to ask us to give us a time or something and come up with however many calories are burned, or how tall you should be after 8 years. Okay, so we got to predict something, and that's going to be step 4. And what we do is we plug whatever they tell us back into our prediction equation that we came up with. We're going to do one example, and it says Alton has a treadmill that uses the time on the treadmill and the speed of walking or running to estimate the number of calories burned during a workout. The table below shows workout times and calories burned for several workouts. Okay, notice we've got time on the top, calories on the bottom. Time is going to be our independent variable, so it's going to be our x's. Calories is going to be our y, because the longer we work out, the more calories we burn. Okay? Now each one of these is a point. This is 18 to 60, 24 to 80, 33 20, 43 80, 42 400, 48 440, 52 475. And notice that last one here has a question mark in it. That's what we're going to predict. We need to predict for 60. Our first step, according to our steps for a scatter plot, is to plot the data. So we're going to take all these points and we're going to plot them. So let's plot 18 to 60, 24 to 80, 33 20, 40 380, 42 400, 48 440, and the last one is 52 475. Okay, so there's our data. Now our next step is to pick 2 points so that we can sketch our line of best fit that's going to match our data pretty closely. Well, I'm going to pick the second and third points here. Those are the 2 points I'm going to go with. Sorry, not second and third, third and fourth. This point here was 3320, and this one here was 4380. Okay, the reason I picked that, if we look, if I extended that on, it's probably going to hit this point here, it'll hit this point up here, so it's going to go through several of the points on our graph. And it goes with our data set. Our points seem to be going up as the time gets longer, or larger, and that's what's happening with our line here. Alright, our next step, okay, we've sketched a line. Step 3 is to determine the prediction equation. Now to do that, we need to figure out the slope of our 2 points that we picked. We got 3320, 4380. So let's figure out the slope. It would be 380 minus 320 over 40 minus 30. That gives us 60 over 10, which is 6. There's our slope. Now we're going to plug it into y equals mx plus b form, solve for b. I'm going to use this point. The only reason I'm going to use that first point is because the numbers are smaller. So we get 320 equals 6 times 30 plus b. You could use the other one. It will work the same way. But again, I'm using that first point because our numbers are smaller. So it's 320 equals 180 plus b minus 180 from both sides. Gives us 140 equals b. Now we rewrite it. Remember, when we rewrite it, x and y stay variables. So we get y equals 6x plus 140. That is our prediction equation. Now the last thing we need to do is predict. That's step 4. Up in our chart, 60 is the one with a question mark. So we're going to go to our prediction equation, y equals 6x plus 140. And we're going to plug 60 in for x because it's a time. And we're going to see what we get for y. So 6 times 60 plus 140. 6 times 60 is 360 plus 140. That means y is going to be 500. So according to our prediction equation, after 60 minutes of working out, we will burn 500 calories. And let's plot that real quick. 60, 500. It would be right here. That looks pretty good. It looks like it would be close to our line if we continued that line through. And that's what we want to see. You don't want to have a prediction that's way over here or something way up here when you're predicting, so that it doesn't match the data or the line that you've drawn in. It should follow pretty closely with whatever data you're looking at. Okay? If it doesn't, you need to go back and pick 2 different points and get a better line of best fit. And then that will change your prediction equation. So we've done this problem correctly. Those are your notes for section 2.5 on scatter plots.